Hello and welcome to another exciting Blender tutorial. Today we're going to be making alien plants geometry nodes using Blender 3.1. About this time last year, I made this tutorial about making alien plants with geometry nodes, and it was really cool. It's going really well, but it's all irrelevant now because geometry has changed so much. So we had a specific pattern that we followed to make this happen, and you pretty much can't follow it anymore. So let's start from scratch. Let's remake this using geometry nodes as it stands now in Blender 3.1. Now, if you want to find out how to do the materials and the textures for this and the lighting and all that, that's in an uncut live stream that I did on Patreon for about a year ago. I can link that in the description below if you're interested to check that out. You can join on the first tier and get access to it. You can also find it if you join on YouTube as a member. All right, so last year when we were doing this tutorial, I started off with this website here, which is on the Blender Stack Exchange. And it's this really cool thread that I found where people were posting up how to create a Phyllotaxis spiral using Python within Blender's code. So this is the kind of pattern that you need to create if you want to do plants, because plants are, a lot of things in the natural world are distributed naturally using the golden ratio and this thing called a Phyllotaxis spiral, which is this really cool distribution of points in a spiral that spread out and create this really nice pattern. You can see it here in this flower really well. We recreated this in geometry nodes, but of course it doesn't work anymore because geometry nodes has changed so much. So we're going to update our Phyllotaxis spiral using the newest version of geometry nodes, but still referencing this code. So I'm going to copy that code here and I will bring it over here. And here we are in Blender 3.1.2. And I'm going to delete the camera. And I'm going to go ahead and select my cube and I'm going to bring this up here. And I'm going to switch over to geometry nodes. So with the cube selected, I'm going to click new to create a new geometry nodes system. Now, we're also going to split our view here and grab the text editor. And I'm going to click new to create a new text, and I'm going to paste the code in from that website. So the first thing we're going to do is we're going to go through and we're going to break out the variables that are in this code. And we're going to talk about what's happening as we do it. I'm going to get rid of the input because we don't need the cube here. We're just going to do it all straight from geometry nodes. And first thing we need is a variable called in. So I'm going to go here and create a value node. I can rename this value node in the label. Let's call it in. And I'm going to give it the same value here, which is 1,000. So there we go. And now we need another one called C. So I'm going to Shift D to duplicate, call this one C. And the value here is 0.1. And this is our scale factor. We can actually just put this in the label as well. So C is the scale factor and N is the number of points. Now we can keep it really clear for ourselves and know exactly what's going on. So we can skip this here. Mesh equals BPY data meshes named spiral. This is just basically creating the mesh itself. And we don't need to do that. We are gonna create some mesh using geometry nodes, but the main thing is this right here. This is the magic loop that creates this spiral. So this is what we need to recreate in geometry nodes. So let's go ahead and get some points. We just need 1,000 points based on this number here. So we're just gonna do the easiest thing, which is to create a mesh primitive, and we will create a line, mesh line. This just creates a line of points. So I want my count to be 1,000. So I'm going to plug my value into the count. If I plug this in here, you can see we get a nice line and it's really tall because there's 1,000 points. Okay, what's going on? Let's talk about this. So for I in range 0, in, and it's all in parentheses. So this basically what this is doing is saying, because this is a for loop. So this is a programming thing where it's initiating a loop. So Blender's Python will run through this for loop over and over again until certain conditions are met. So the conditions are for I. So I is going to be a new variable that's being created. Every time the for loop runs, it creates this variable I, and it's saying I is in a range of 0 to n, and n is 1,000. So from 0 to 1,000. So it's going to run through this loop basically 1,001 times. 1 meaning we start with 0, not 1. So it's going to be 1,001 times. And every time it does, it's going to assign the value that we're at. So if we're at number 50, let's say, turn number 53 of going through this loop, it's going to assign the number 53 to I. 54 will assign 54 to I. So I just basically iterates up with each iteration. And then we're just using that number as it goes up in this chain of 1,000 to do different things to the math. So what we do here is I create a couple of different variables. So first thing we're creating this variable called theta, which is going to be I. So the number that we're at, whichever point we're at. times math.radians, and then 137.5. This is the golden ratio. So this is the ratio that we can use to calculate the spiral. This is the special number that makes it all happen. So let's see, how would we recreate this in geometry nodes? Well, okay, we need to make theta, and we need it to be I, which is going to be the number that we're up to. So we're going to cycle through all the different points. Now, if you remember, if I open up here, go to my spreadsheet, here it is. So this right here, you can see it lists out all the different points that we've got. We've got 1,000 vertexes in our thing because we've created it here. So we need to cycle through each one of these, and that's the same as cycling through each one of these here. So I hope that makes sense, how that's all working. So we need to take I, which is going to be the number. So we can just use the index number for this. So, which one are we up to? Because we're going to cycle through each of these one at a time. So let's take the index. So I'm going to type in index. I'll just bring this down here. We'll map this out down here. So we take the index number that we're at, and we're going to multiply this by, so I'll grab a math node. We're going to multiply it by math.radians and 137.5. So what this is saying is it's using a function here, math.radians. This is a Python terminology, the dot, and then, so it's like math is the big function, and radians is the bit that it wants, like the specific calculation we're supposed to do, and 137.5 is the number we're doing that calculation with. So it's the same here. The big thing is the node. We want to use a math node, so math node, right? And the next thing, which is radians, we want to do a radians calculation. So we want to say we're going to do a 2 radian calculation right here, and the number we want to have is 137.5. So this is the number we're doing the calculation on. And we want to multiply that by I, which is the index. So we need to get another math node. We can just duplicate this and go set this to multiply. So we'll take the index and we'll take this calculation here. And this gives us theta. So we can actually label this theta if we wanted to, just so that it's really clear that this is the same as what's going over here. We can even drop these down, so we're not even thinking about it anymore. So, okay, there's theta. Now we need R equals C times math, the square root of I. So again, it's kind of easy to think about this in geometry nodes. Usually you kind of work backwards and when you're building this stuff out. So let's get the math square root of I. So let's go math right here, and we're going to find the square root function. So where's the square root? There it is. And we want the square root of I. I is going to be the index. So there we go. I'll put this next. Or actually, we could actually, copy the format of the code and just go down. So we've got theta, and then we need to get R, which is going to be, so what is C again? C is the scale factor. So we need to multiply the scale factor by the square root of I. So this is square root of I. So let's get another math node. And we're going to set this to multiply. And we can grab the scale factor and pipe that in. And then we can take this and pipe that in here. So now we're multiplying those together. And now this is R. Here we go. So we've got theta and we've got R. All right, now what do we do with theta and R? Okay, we get bm.verts.new math cosine theta times R math sine theta times R 0, 0. Obviously, we're going to just make a spiral using that, right? That's what's going on. So, all right, so let's break this down. So bm.verts.new, this is a like a Blender Python script thing that creates new vertexes. So the vertexes, unlike us, we've already created ours. We've made our line with our 1,000 vertexes. This one, the way the code works is they first create the mesh, but the mesh is empty. And here they're creating the vertexes kind of as they position them. So we've already got ours created. So we just need to move the ones we've made. So that's the difference between us and this code. So let's figure out what's going on inside here first, and then we'll kind of break it out. Okay, so also the other way to think about this too is where it says bm.verts.new. It's basically saying, okay, this is the X, Y, and Z position of the new vert. So create a vertex and place it here at this point in 3D space. That's why these commas are here, right? So we've got the comma, comma. So this is the X, this is the Y, and this is the Z. So Z is just going to be 0. That's why it's comma 0, 0 there at the end. Z is always going to be 0. It's going to be flat. And then we've got math.sine theta. That's the Y, and the X is math.cosine theta times R. So let's do that. So let's get another math node right here, and we're gonna set this one. So we're gonna do the cosine of theta. So let's find cosine. There it is. and we want to grab the cosine. Oh, there's theta, bingo. And then we want to multiply that by r. So I can come here and set this to multiply. And we'll take this value and plug it in here, and we'll take r and we'll plug it in here. There we go. So we've just done this bit. So this is the x position of things. So I can actually just label this now. We call it the x position. So we now have the x position of our vertexes. Next, we want to have math.sine theta. So let's go for another math node. And we want to use the sine function of theta. There's theta, plug it in. So the sine of theta, and that's all we need to do there. And we need to multiply it by r. So we come over here, set this to multiply, and take r. And this is going to be our y position. So we've got our x position and our y position. And then z is just going to be 0, right? Okay, so now we need to actually apply all this math that we've just done with this little setup here to this mesh line. So it's kind of cool actually looking at this and thinking this here, this little loop represented in nodes looks like this. It's kind of cool. All right, so let's come over here and we'll go set position, because that's the node we always use to move the position of vertexes. I'll drop this here. And we would just want to set the position of all these guys. So we need to, first we need to turn these into a vector, because these are just individual numbers. See, the color's gray, so that means it's just a single floating point number. So we need to go for a combine x, y, z node, and we'll take the x and we'll pop it in here. We'll take the y, pop it in here. We're going to leave z 0, remember, because that stays 0. Now this new vector that we've just made, we can set this into the position. And bam, you're going to see it works instantly. There we go, all the points. Now we've got these edges that connect everything, but you don't have to worry about those. We're not going to be using the edges. So what's really matters is the vertexes, wherever they are in this. So if we want to visualize this a bit clearer, we can go for a, let's see, an instance on points node and drop this here, and then grab a mesh primitive. And let's grab an isosphere maybe, and we'll crank this radius down to like 0.1 maybe, and we'll plug this into the instance. And now you can see that we've got the Phyllotaxis spiral looking good. And we've got the number of points, so we can decrease these, and that will decrease the amount of points we have. And we have a scale factor, which basically just determines how far they spread out. You might be a little confused if you're not used to the way this is working, like why these nodes apply to everything. And one of the things to remember is right here, when we are saying set position, all these nodes and geometry nodes, they operate as a loop, basically. So they're going to take every point, which is there's 1,000 points here. If we put that back up to 1,000. And it's going to cycle through, set position cycles through every single point, right? So it's automatically going to be doing this by running through every point. And you can tell that with this dotted line. The dotted line represents a value that's going to change. It's looping through each iteration. So just automatically by using set position, it's going to loop through this every time. And every time it loops through this, it's going to look at this chain, and it goes right up to the end here, and it sees, oh, we're taking the index of whichever one we're at. So when we start off, if you look at our spreadsheet, it's going to go through every single one of these, and it's going to say, oh, okay, so what do you want me to do to it? It goes back here and says, oh, index. All right, so we're at index 9, let's say. Okay, so I'll take the number 9 now, and I'll do all this math using the number 9. So these numbers stay the same. You can see that's a solid line, not a dotted line, the 2 radians. So that means this number is always going to be the same every time it runs through. But the dotted ones tell you this is a number that changes each time it iterates. So this number is going to be different because it's always going to be a different index number. And that's the only thing that really changes with this math. These things always do the same thing. And these get dotted again because now they've been multiplied, or an operation has been done with this index number. So now it's a unique number. So it's going to change every time. That's why these are the only ones that are solid. So that's what's happening. And it combines it all, brings it up here, and then it'll set the position. Then it moves to the next one automatically. This node will jump to the next one, go to number 10. All right, great. So that's how we update the geometry nodes. So now let's just finish this thing out and make the cool alien plant like we did last time. Okay, so next thing we need to do is round out this shape a little bit. So it looks like the surface of like a flower. So we're just going to, not unplug things. So So we're just going to add a little bit of curve. So we're going to create another set position node. So we're going to go set position, drop it here. And we're just going to offset the position of all these points a little bit based on a curve. So I'm going to grab a gradient texture. I'll set it from linear to spherical. It will create like a round shaded gradient. It's like a circular gradient. And we can use this with a, let's say a color ramp, right? And we can plug the color into the factor, and then we can just plug this color directly into the offset. Now things are going to skew off in a weird direction, right? But that's because this is looking for X, Y, and Z position, and we've just fed it a color ramp, which is giving it red, green, and blue. So we just gave it values in RGB. So it translates these into X, Y, and Z. So it's moving the points based on this gradient in the 1, 1, and 1 direction. That's why it's skewing off, up, and this way. So if we just wanted to go straight up, we can just come in here to the colors, and we can actually just turn on the red and the green and just keep blue. You can see blue represents Z now, and it's just going up. So, okay, this circle's not quite big enough. The gradient, you can see it's also quite linear. So I'm going to set this to ease. That'll kind of curve it a little bit, but we need the edge to be beyond the edge of our actual circle ring here. So we need to basically cause this gradient texture to get bigger. So we need to take the position of every point, which is basically what it's using automatically to place this, the position of all the points. So this is kind of like the texture coordinate node if we're going to use just generated or object, something like that. So this is what's going on already. So we can just come here and grab a vector math node, drop it right here and set this to multiply. And then we can increase this. And as we increase this number, as we decrease the number, there we go. So like 0.2 looks pretty good. And then we can adjust it, of course, with this if we want to kind of flatten it off the top a little bit. All right, now let's get some actual mesh to go in where these guys are. So I'm just going to create something over here. So I'm going to go Shift A and I'm going to create a UV sphere. I'll just grab it up so I can see it. I'll bring this down a touch. There we go. I'm going to right click Shade Smooth and I'm going to go into edit mode and I will just scale it on the Z a little bit like that. Like this right here. Let's see, I'll go to Faces, C to grab brush selection. I'll hit C to grab brush selection and I'll click this top bit here and I'll actually just delete those faces. And then I'll go to edge mode, hold down Alt and click that and that'll grab the edge loop there for me. And then what I can do is hit E to extrude, scale that in, grab that up on the Z, E again and grab it up, scale it right down, E and grab it up, scale it down. I'm just making like a little like round tip thing. Go, and then I'm going to hit F3 and type in grid fill, and that will fill in that with a grid of faces. Cool. Might take this edge loop and grab Z to bring it down. Grab this edge loop, Control B to bevel just to split it out. Maybe roll my mouse wheel once to create a little bit of an edge there to that bevel. And that looks pretty good. All right, so we're going to call this thing our the bud, I guess. We'll call this our flower. And so now I can grab the bud and use this as the mesh. So grab this back up. And we will come over to where we instance on points. And I'm going to grab an object, info node, and we're going to grab the bud object, and I'll plug the geometry into the instance. Get rid of that. And now we need to change the scale. So I'll grab each of these guys and I'm just holding down Shift as well so that I'm scaling slower. I'm just going to go up till they all intersect like that. Very cool. All right, now we need to create a little bit of variation, some randomness in their rotation and in their shape. Let's go to the rotation here and I'm just going to insert some random rotation. So I'm going to type in the word random and I'll set this to vector. And the ID, we'll use the index again. So the ID is just basically, how do I know which ones to do this to? So I'll just plug the index in and it'll just feed the index in each time. So it'll pick out each point. And let's set all this to the 0 rotation. And we'll plug it in so nothing's going to happen. But now what we can do is we can slightly turn these up a little bit. And it's going to start to rotate these guys in some cool ways. So I'll just do just a little bit. Same with the scale. We should do that as well. So I'll just duplicate this. I'll set all of these to 1. I'll plug this in as the ID. And let's see, actually the scale I'm going with is 0.21. So I'll come over here, So set the scale so it's all the same, and I'll plug this in. And then what we can do is we can change these a little bit. Although for this one, what we should do is set this to float, because we want this X, Y, and Z scale to all be the same. So if we plug a float into a vector, it's going to use that one number to populate all three, the X, Y, and Z. So this will keep it from keep them from getting squishy or really long or something weird like that. So now I'll hold down Shift and I'll just drag just a little bit. All right, now I want to change them up a little bit so that the stem here is not just straight up for everything. So we're just going to select the mesh here, go into edit mode, and I'll just go to transparent mode. And I'll just grab a box around this top section here. And then turn on proportional editing up here. And we're just going to grab maybe on the Y and just roll your mouse wheel until you get like a nice fall off. And I might rotate as well a little bit. Now you notice all of these guys are now curving in the same direction. So we just need to go back to our rotation here, random value for the rotation, and just increase the Z rotation a bit so that it picks a random Z rotation. Turn these off so you can see. And that really helps a lot because now they're all kind of pointing off in different directions. All right, now we need some leaves to kind of pull out around this thing. So let's go ahead and create that. I'm going to go Shift A and I'm going to create a, let's see, a plane. Just drag it over here so I can see it nice and clear. And I'll bring my geometry nodes window down. So I'm going to go into edit mode and hit Control R to create a loop cut right down the middle. And then I'm going to create a few loop cuts like this kind of across it. So I just did 1, 2, 3, 4. And now what I can do is go into vertex mode and I can just grab these two outer ones and scale X, turn off proportional editing, scale X, bring them right in. And then I'll grab this guy, scale those in a little bit. And then I'll grab these two, bring them in, these two, bring them in, these two, and bring them right in. And then I might grab this one and push it out on the Y a little bit. And then I'll turn proportional editing back on, grab Y, roll my mouse wheel to kind of extend this thing out like that right there. And then I might grab this and Control B to bevel once. And I will roll my mouse wheel once, so I've got a cut in between them. And I'll just drag that out some. It's pretty good. Now I'll hold down Alt and grab that center one and turn off proportional editing. Grab Z and bring it down a little bit just to create a little sort of divot. And then I want to turn proportional editing back on, grab Z and just lift it up. And that will kind of curve these guys down. Now I might want to actually create a little more geometry here. So I'm going to do a loop cut there and there by hitting Control R. And then I'm going to grab this with Alt and this with Shift Alt and grab Z, turning off proportional editing. Grab Z just to pull that down a touch. Select all of it. Rotate Y 180. There we go. I'm right click shade smooth as well. Grab my proportional editing. Look at this thing from the side. I'm also going to put a subdivision surface on it. I'm going to grab this center group here, Control plus to expand it, and then turn off proportional editing, grab Z, and I'll just bring it down like that. And then I'll just Alt click that middle one and bring it right down to really get that crease to work. It actually uses the same kind of system. So a Phyllotaxis system. So let's just take all of this, right? So I'll take all this, all this, all this, and this. And why not this, this, and this? And let's Shift D to duplicate and bring it all over here. And then what we'll do is instead of number of points and number of points, we'll just drop this down to like maybe 10. And we'll still use a mesh line, but then we're going to instance these guys, the leaves around it. So let's grab object info, and we'll grab the leaf, and we'll plug this geometry in as the instance. And then we're going to join geometry, drop this here, and we'll plug this one into here. We need to adjust all of our, I'm going to unplug the rotation and the scale for now. Go. Now it's working, even though it doesn't look like it. It's just not rotating them correctly yet. So I actually need to rotate them based on where they're at. So let's take a I'm gonna get rid of these random value ones for now. Now we also need to scale the Phyllotaxis thing up for the second one. So we'll take the scale factor up so that it's roughly the same size as the outer. All right, let's say, let's see, align Euler to vector is the special node we need to use. We're gonna plug this into the rotation. And we are going to use Z, and I'm gonna grab a normal node. We'll keep it on X actually. And I'll plug that into the vector. And then let's just cycle through these to find the one that works. Y looks like it's good, it's just the wrong rotation. All right, great. So this is working with the align to Euler vector set to Y, but they're facing the wrong direction. So we just need to go into edit mode with this guy. So we'll go to the leaf, select all the points, and then rotate Z 180. That'll just flip it around. That's one way of solving it. Now they're all working. All right, so let's get this to look good. I'm gonna scale them up so that they're bigger. And I wanna get the number of points to be something that looks nice here. They really spread out nicely. Looks good. And now we need to change their overall size. I wonder too, like let's go into edit mode on this leaf. What happens if we grab Y and just spread them out? Yeah, there we go. See, that looks good. Now they can all be forward a little bit. And then we could probably even do this here. If I just rotate on X and then grab them up, set them in the right spot. So let's try that. We'll use the same kind of system here that we use to offset everything. And we'll plug this group in to the geometry, unplug it here, and we'll plug it back in. We need to invert this. So let's take some vector math, and we're going to multiply by -1. So we'll plug this in here. And we'll plug this in the offset. This will drop them down. And dropping them down seems to solve it pretty well. Go back to my leaf and I'll just enter edit mode again. And I'll just play with these a little bit. All right, cool. So now I just need to delete a few points. We've got a couple of points here in the center that we need to get rid of before we instance them. So if we come over here to this section right here, I can actually just do a bit of math and set this to less than, and then grab the index, and I can throw the index in here, and then I can grab a delete geometry node and drop it here, and I can use this as the selection. And now what I can do is I could say, all right, everything that's less than 6.5, for example, in the index, or 6 in the index, get rid of it. So that'll kind of get rid of those innermost ones. Which could help a little bit. There we go. That should be fun. Yep. There we go. And I might shift D to duplicate. Bring this one over here. But overall, this is how we can apply the new geometry nodes system and the new nodes that we've got to work with to the same ideas that we had in that original one. So I hope you found this really useful and helpful in figuring out how to create Phyllotaxis spirals using geometry nodes in Blender 3.1. Thanks so much for watching. I hope you really enjoyed. Don't forget to hit the like button and subscribe to the channel if you want to find out when I launch new tutorials. Ring that little notifications bell. And I will catch you in the next tutorial. Until then, have a great week. See you later. Bye.